Well, hello, we've got a nice topic for you tonight. We're going to start with Introduction to Rational Functions. So, this is the definition of what a rational function is. Basically, it's a ratio of polynomial functions. Now, ratio hopefully sounds familiar. Kind of is in that word rational. Okay, you see the word ratio. Ratio, of course, is just a fraction. And, of polynomial functions mean functions with many terms. So, for example, something like 4x plus 4 over x squared minus 1. This is considered a rational function. It's a ratio of polynomial functions, a fraction with polynomials. Exercise 1. Consider the rational function given by f of x equals x plus 6 over x minus 3. Now, I just want to remind you why it's called rational. That word ratio is in there. It's the ratio of two polynomial functions. So part A says determine the y-intercept. Alright, so I just want you to box in y-intercept, and we'll just make a quick little sketch off to the side. When you have a y-intercept, that's where it hits the y-axis, there's a value that's always true. The x value is 0. It doesn't matter if my graph hits up there or down here, the x value is 0. So to find the y-intercept, I'm just plugging in 0 to x. So I get 0 plus 6 all over 0 minus 3. Those cancel. 6 divided by negative 3. I get a y-intercept of negative 2. Part B. Algebraically determine the x-intercept of this function. Alright, well, let's do the same idea. Let's make a quick little sketch. Let's get an x-intercept. That's where I cross the x-axis. What do I know there? Well, I don't know the x value, but I do know that the y value is 0. Okay, so this time I'm setting my equation equal to 0. And the hint says a fraction can only equal 0 if its numerator is 0. So when I set a fraction equal to 0, I'm really just setting the top equal. So if 0 equals x plus 6, x equals, subtract that 6 over, negative 6. C. For what value of x is this function undefined? So this is going to be a big keyword for us this year, so let's get down a definition here. Undefined happens when the denominator equals 0. Let's get in our notebook. You might want to highlight this word undefined so we can find it easily. That happens when your denominator equals 0. So if I say x plus 6 over x minus 3 is my function, alright, and every time I see that word undefined, I'm strictly saying when does my denominator equal 0? So I'm really just saying when does x minus 3 equal 0? We'll add that 3 over, and I get x equals 3. This is when my fraction is undefined. So basically what undefined is saying, that is the only number in the entire world you are not allowed to plug in this function. Alright, I can plug 1 in, I can plug 2 in, I can plug 5 in, I can plug negative 1,500 in. The only number in the world I can't plug in is 3. Okay? Part D. Based on C's answer, state the domain of this function in set builder notation. Well, if 3 is the only number I can't use, I could say I can use all numbers from negative infinity till 3, but don't include 3, and from 3 to positive infinity, but don't include 3. Or I can use my other notation and say all my x values have to be less than 3, or all my x values have to be greater than 3. Or I could say I could be every real number except the number 3. Basically, you could just say x cannot equal 3. So there's lots of ways to say the same thing. Just pick the one you're comfortable with, and we'll just make sure we understand the meaning of all of them. But either way, x cannot equal the number 3. Exercise 2. Find all values of x for which the rational function is undefined. Okay, so there's our keyword, undefined. And we just said undefined happens when our denominator equals 0. Okay, that is when a fraction is undefined. So it says verify your answer using your calculator to evaluate the expression for these values. So all we're going to do is we're going to take our expression, x plus 5 over 2x squared plus 11x minus 6. And we're going to do our favorite thing in math, and we're going to factor that term. Now, you obviously can't factor the top, but we can factor the bottom. All right, and we have a nice little guess and check. Remember, we're multiplying, adding, multiplying. And I love this one because my only options are 2x and x. And then on this one, I've got 3 and 2 or 1 and 6. Now, two things to keep in mind. If I'm multiplying to a negative, I know I need one sign to be positive and one sign to be negative. And remember, there's no quick way to guess and check. You just kind of plug them in and see what happens. I'm going to try a 1 here and a 6 here. And I'm going to check the outsides and insides. That will make 12 and 1. And then I can get an 11 out of that if I make my 12 positive and my 1 negative. So now, if I want my fraction to be undefined, it's really just when does this bottom equal 0. So basically, I'm just going to tee up the bottom. 2x minus 1 times x plus 6 equals 0. And if I tee it up, I get x equals 1/2 and x equals negative 6. Now, of course, maybe I skipped a step for you. I'm just setting both of those equal to 0 and subtracting and dividing that 2 over. The next part of the directions said check on your calculator. So here's what I did. I took my negative 6 answer and I replaced all my x's with negative 6. Now, one of our biggest mistakes is watching parentheses. Notice I put that negative 6 in parentheses every time I substituted it in. When I hit enter, this is what my message told me. It says error, dividing by 0. You're not allowed to divide by 0, which means negative 6 makes our fraction undefined. So we know we're correct. We're not allowed to divide by 0. And then I could do the same thing with the 1/2. Exercise 3. Which of the following represents the domain of this function? Now, typically when I see the word domain, I think I'm going to graph the function. All right? And I'm, of course, going to use my calculator. I may not know what that looks like off the top of my head, so I'm going to graph it in my calculator. Now, there are two things I want to talk about. We can't be undefined in our domain. All right, so I'm going to figure out when is this fraction undefined. And remember, undefined is when you have the bottom equal to 0. So if I quickly factor this, let's see, 16, I got 4 and 4, 1 and 16, or 8 and 2. I'm going to say that's x minus 8 and x plus 2 equals 0. When I tee those up, I know x cannot equal 8 and x cannot equal negative 2. So if I look at my choices, basically every number in the world will work except those numbers. So you'll notice they all say does not equal. Okay, every number will work except 8 and negative 2. All right, so like I said, the second way to think about a domain is to look at the graph. And remember, we're just looking at the x values. So here's what I typed in my calculator. If you have the update, you have that fraction tool, the alpha y equals. If you don't have the update, remember, you just have to type the top in with parentheses divided with the bottom in with parentheses. So here's what my graph looks like, and it's kind of strange looking, and I'm going to teach you a new word you probably haven't heard before. So I want you to just pause the video, and I want you to sketch this in your notebook. Now, you'll notice this graph comes down, and this graph goes up, but what I want you to draw in is this vertical dashed line here. And you'll notice that is at x equals negative 2, which happens to be when we got an undefined point. And you'll notice one again here. This one comes down, this one goes up, and that happens right at x equals 8. Okay? And what those are called, when our fraction is undefined, and this is what we need to put in our notebook, when our fraction is undefined, it creates vertical, so that means straight up and down, asymptotes. All right, we're going to use this word quite a bit as we get into our higher level math and our trig. We create vertical asymptotes, and that happens when our fraction's undefined. You'll see these lines get closer and closer, but they actually don't touch to negative 2 and they don't touch 8. Exercise 4. If g of x equals 3x minus 2 and f of x equals this rational function, remember rational, ratio of two polynomials, 2x plus 1 over x plus 5, then find the following. So a little bit of review in here. All right, so if I want f of g of negative 2, remember I'm going to take negative 2 into g. So I'm first finding g of negative 2. So let's see, 3 times negative 2 is negative 6, minus 2 is negative 8. Now I'm going to find, go backwards, f of negative 8. So I'm going to carefully substitute that in. Watch your parentheses. 2 times negative 8 plus 1 all over negative 8 plus 5. So I get f of negative 8. On the bottom I get negative 3. 2 times negative 8 is negative 16 plus 1 is negative 15 for a total of positive 5. Let's try the next one. I'm taking, remember, go backwards. 2 goes into g. Alright, so I'm finding g of 2. So that's 3 times 2 minus 2. So 6 minus 2 is 4. So now I'm finding 4 into f. So f of 4. So nice parentheses. 2 times 4 plus 1 all over 4 plus 5. Let's see, that's 8 plus 1 is 9 over 9 gets me a 1. Alright, next example. I'm taking g of x into f. Okay, I'm taking this whole function into f. So I'm going to say I get 2 times, plugging in g of x, 3x minus 2 plus 1 all over 3x minus 2 plus 5. Alright, so again, this should just be review. We're taking g of x into f of x. Watch the distributing there. So that gets me a 6x minus 4 plus 1 all over, let's see, 3x, and I have a minus 2 plus 5 gets me a plus 3. If I keep going, that looks like 6x minus 3 all over 3x plus 3. Now, we're not done on this bad boy because we can take that rational function and simplify. Remember, it always comes back to factoring. What type of factoring can we do on top? Well, I think we could pull out a 3, nice little GCF. Now remember, I have to have something minus something, so I've got 2x and then the minus sign. What's left there? You're right, a 1. Make sure you always divide that out. And on the bottom I could pull out a 3, and I'm left with x plus 1. Again, make sure it's something plus something. And then this 3 on top can factor with this 3 on the bottom, and I would say that my final answer is 2x minus 1 all over x plus 1. Exercise 5. Find formulas for the inverse of each of the following simple rational functions below. Recall the first step is to switch the x and y. So remember, inverse means switch the x and y, and then solve for y. So we did these earlier on, but now these just get a little nastier, and you'll see why in a moment. So my first step on A here, I have y equals x over x minus 2, is to switch the x and y. Now, can you tell why they're a little nastier? When we did this in the old days, we only had one y. Now I'm stuck with two y's. So here's the deal, guys. You cannot cancel these y's whatsoever because we did not factor. What you can do is make this over 1, and when there's an equal sign, you can cross multiply. Alright, so I put that over 1, and I'm just thinking cross multiply. So 1 times y is y, and then I'm going to say this is x times y minus 2. Alright, so if I keep going, I get y equals, distribute that, xy minus 2x. Okay. Now my goal is to get the y's on one side. There happens to be two y's. So I'm going to say this is y minus xy equals negative 2x. Okay, I just brought the y's over. And now, it comes back to that favorite F word, which I know you're thinking is factor. I'm going to pull out a y from each one, a nice little GCF. Take out a y, and y divided by y is 1 minus x equals negative 2x. Lastly, I'm going to divide over the 1 minus x, and I get y equals negative 2x over 1 minus x. And there you have it. Now, let me just show you an equivalent answer, just to be clear. You could, let's write the word equivalent. An equivalent answer is to have the complete opposite signs. So what's the opposite of negative 2x? Well, you could have positive 2x. The opposite of positive 1 is negative 1. And the opposite of negative x is positive x. I just want to be clear in case it's multiple choice. These two answers are equivalent. They mean the same thing. So let's go back and try the next one. Okay, it's very similar. And see if you can get the first couple steps on your own. Alright, our goal is to find the inverse. So your first step should be switching the x and y and cross multiplying. Pause it, see how far you can get. Alright, I'm ready to walk you through it. I switched my x and y, so I'm putting this over 1, and I'm cross multiplying. 1 times y plus 3 is just y plus 3. Then I'm going to say it's x times 2y. Okay, so I've got y plus 3 equals 2, an x and a y. Remember, you have to get the y's on the same side. So I'm going to, whoops, I missed my equal sign. I'm basically going to move the 3 this way, and I'm going to move the 2x that way. So I'm going to say y equals, I'm going to subtract the, whoops, sorry about that. I'm going to say y, I'm going to subtract that 2xy over, and I'm going to subtract my 3 to the other side. Alright, so hopefully I didn't lose you. I just subtracted this one, and I subtracted that one. Then I'm going to factor our favorite GCF, factoring out a y, and I'm left with, this doesn't disappear, I get a 1 minus 2x equals negative 3. And then to solve for y, I'm just going to divide both sides by 1 minus 2x. And I get y equals negative 3 all over 1 minus 2x. Alright, now can we come up with an equivalent answer? What is that equivalent to? Remember, you just need to make everybody the opposite. So instead of a negative 3, I could have a positive 3. Instead of a positive 1, I could have a negative 1. And instead of a negative 2x, I could have a plus 2x. And those are just equivalent. And the only reason I'm showing you this is in case, you don't see that choice, make sure you get an equivalent answer. Alright, we've got 2 more to try, very similar. Again, we're going to find the inverse here. So I really suggest pausing it, trying it on your own, and turn it back on when you need to hear what I have to say there. The more you practice on your own, the easier this will be for you in class tomorrow and in the future. So remember, switch the x and y, get the y's on one side, and pause it, see how well you do. I'll show you what I've got so far. I've switched my x and y's, put it over 1, and I'm cross multiplying. 1 times y minus 1 is just y minus 1. I get x times the y plus 1, and now I just take that x and distribute it through. If you've got to that point, you're halfway there. I'm going to put the y's on one side and everybody else on the other side. So I'm going to bring this xy over by saying minus xy, and I'm going to bring this 1 over by adding it. Okay, so now I have anybody with a y on one side, and remember, it comes back to our favorite word, is that factor word. I'm going to pull out a GCF, and I'm left with, if I pull out a y, I have 1 minus x. Okay, remember, take 2 seconds. If you distribute this back through, do you get what you started with? Equals x plus 1, and then just simply divide both sides by 1 minus x. So I get, and let's go ahead and write our 2 answers down, y equals x plus 1 all over 1 minus x. Or I could say that's equivalent to, remember, just negate everybody, negative x minus 1 all over negative 1 plus x. Those two, remember, are equivalent. Alright, last one of our inverse practice. Again, pause it, see how far you can get, and turn me on when you need to. So again, hopefully you're good up to this step. I've put it over 1. I've cross multiplied, distribute my x. And again, I just want to put anybody with a y on one side and anybody without it on the other. So I'm going to say this is 2y minus xy equals, I have a negative 4x plus 1. Pull out my favorite factor of a y, and I'm left with 2 minus x equals negative 4x plus 1, and divide both sides by 2 minus x. So I get y equals negative 4x plus 1 all over 2 minus x. And I just want to be clear, that's equivalent to, just change everybody's sign, positive 4x minus 1 all over negative 2x, or I'm sorry, negative 2 plus x. And there you have it. Nice job on the inverses. Our last question for the night. Which of the following is equivalent to this? Alright, so I've got 2x minus 10 all over 25 minus x squared. Now, what does your gut tell you to do? And again, I can't keep stressing this word. It all comes back to factoring. If you're not sure, think factoring. Alright, what type of factoring do we have on top? Well, I would say we could pull out a 2 as a nice GCF. Okay. What type of factoring do we have on the bottom? Well, because there's two terms, I think GCF, but I don't see one. So then I go to perfect squares as my next option. Let's see, if the 25 came first, I need to say that's a 5 minus x and a 5 plus x. Okay? Now, is anybody the exact same? I would say no. This x minus 5, I don't see exactly down here, but I do see a 5 minus x. Alright, now if you're not sure if they cancel to a positive or a negative, just pick 0 and plug 0 in. What is 0 minus 5? Well, that gets me a negative 5. And what is 5 minus 0? That gets me a positive 5. Therefore, they do cancel because they both deal with the number 5, but they cancel to a negative. So this guy does cancel with this guy, and we always put this negative on top. Alright, a nice negative 1. Now, what operation are we doing here? Well, remember, that's multiplying when things are next to each other. So I get negative 2 all over 5 plus x. Negative 2 all over 5 plus x. And you'll see that is a choice. Now, they can certainly reverse the 5 plus x and x plus 5, they mean the same thing. But if that wasn't a choice, I just want to be clear, that's equivalent to, change everybody's sign, I could have a positive 2 all over a negative 5 minus x. I just want you to keep in mind that those are equivalent answers. Well, that does it for us tonight. Hopefully this was a nice, easy intro to rational functions, and we look forward to seeing you tomorrow.